Next, we go on to the run-up contest for the 2006 MIT Integration B finals. And the problem that was the first problem was the indefinite integral of sine of x minus cosine of x over the square root of sine 2x. So this is quite an interesting problem, but let's see how we may be able to solve it. So the first thing, obviously, we would like to do is identifying patterns. You want to look for patterns here. And I look at the numerator and it looks like it is something that has a relationship with the denominator. But I would like to first of all begin by expanding the denominator. Sine 2x is the same as 2 sine x cosine x, which means that if we express the numerator as the derivative of negative cosine x minus sine x, then we can pull out the negative sign here. We can, these two negative signs, we can pull them out so that we have a negative of the integral of the derivative of cosine x plus sine x over 2 sine x cosine x. Now you can see the easy relationship between the numerator and the denominator now. 2 sine cosine x is the same as cosine x plus sine x squared minus 1, because cosine x sine squared x plus cosine x plus sine squared x is equals to 1. So knowing that, it is a general rule in integration and calculus that you would like to substitute off for items that look common. And so the next thing I'm going to do is I'm going to say let u be equal to sine x plus cosine x. And that what that means is that du dx is equals to the derivative here, which is the same thing we have in our numerator. And so du can be used to substitute the derivative of sine x and cosine x times dx. Then what we now get is that our negative, the integral of derivative of cosine x plus sine x over the square root of sine x plus cosine x squared minus 1 is the negative integral of 1 over square root of u squared. So this now has become a more tractable integral. And for those of us who know hyperbolic functions, we know that let me probably write it a little bit better because I messed up a little bit, but we know that cos squared of x minus sinh squared of x is equals to 1. So cos squared x minus 1 is equals to sinh squared x. So if we substitute u for that, then it means we can rationalize the denominator very easily. So let's say u equals to cos y. That means du dy is equals to sinh of y. And so what that means, we can substitute du with sinh y dy. So negative of 1 over square root of u squared minus 1 is equals to negative of sinh y over square root of cos squared y minus 1, where the denominator now becomes sinh y. And so the numerator and denominator can cancel away. And so we have the integral, the negative integral of 1. And that means that our answer is, when you integrate 1, y plus the integration constant c. So having our answer as negative y plus c means that if we know that u equals to cos y, then that means that y is the arc cos, the hyperbolic cosine, arc hyperbolic cosine of u. So we just go in and plug our initial integral, negative integral of 1 over square root of u squared minus 1 is equals to negative cos of u. But we also know that u is equals to sine x plus cosine x, meaning that our original integral of sine x minus cosine x over square root of sine 2x is the negative arc cosh of sine x plus cosine x. But this actually is a sufficient answer in some quarters, but you could also want to express it in a certain way. So let's assume that k is just arc cosh of sine x plus sine x. That means that cosh of k is equal to sine x plus cosine x. And we know the definition of hyperbolic cosine. This is e to the power k plus e to the power negative k over 2. So this is equal to sine x plus cosine x, meaning that if we multiply 2 across both sides, we have e to the power k plus e to the power negative k equals to twice sine x plus cosine x. And that means that e to the power 2k minus 2 times sine x plus cosine x plus 1 equals to 0. And so this becomes e to the power k minus sine x plus cosine x squared minus, obviously, the square part of sine x plus cosine x plus this 1 still there equals to 0. And sine squared x plus cosine squared x is equal to sine squared x plus sine squared x plus 2 sine x cosine x. And since the sine squared x plus cosine squared x equals to 1, that negative 1 cancels with this 1. And so you are left with e to the power k minus sine x plus cosine x all squared minus 2 sine x cosine x. Take this to the right hand side, and so we have e to the power k minus sine x plus cosine x being equal to 2 sine x cosine x. Square root on both sides, we have e to the power k minus sine x plus cosine x equals to square root of 2 sine x plus cosine x. And then adding sine x plus cosine x both sides means that we have e to the power k being equal to sine x plus cosine x plus the square root of 2 sine x cosine x. And the log of e to the power k means that is k, which is equals to log of sine x plus cosine x plus the square root of sine 2 sine x sine x 2 sine x times cosine x. So therefore the integral of sine x minus cosine x over square root of sine x sine 2x is equals to negative, since we didn't include the negative sign, negative natural logarithm of sine x plus cosine x plus 2 sine x cosine x, or you could say this is the same as natural logarithm of sine x plus cosine x plus square root of sine 2x plus the integration constant. And that's the answer that was expected. So well, that was it. Quite a long and windy solution. Thank you for hanging out with us. If you haven't subscribed to our channel, we do encourage you to subscribe to our channel. Until next time, bye bye. Hasta la próxima.